So we are going to start with a hackathon. Okay, the hackathon results. I know that you're having a very nice lunch, but it will be nice for you to take a look at our hackathon results. So if you can pay attention a little bit, that would be awesome. So now Thomas is going to present our SLT Hackathon 2022 and also the best projects that we had. Okay, thank you.
Thank you for coming. So the hackathon was the first time we had a speech and language technology hackathon here associated with SLT in Doha. The goal was to build and strengthen a community of speech and language technology experts and enthusiasts. The goal was also to have a collaborative hackathon, which is a bit unusual, I think. We were able to attract 97 participants from more than 30 plus countries. Most of them actually were remote. They worked on 18 different projects. You can see they worked across different time zones. We had a wonderful group of 5 volunteers and very, very resourceful mentors and useful project mentors for them. As said, the hackathon happened in 18 projects, and a lot of teams were actually quite distributed over the globe. On the right side, you can see actually a picture that we might see. So the timeline actually is that the hackathon started in October with a pre-registration of teams that are interested, or not teams, individuals who are interested in speech and language technology. Who are supposed to submit also on the same day a big idea. Actually, we moved the registration to the big idea. On October 26th, we went to the big idea. We invited the team participants and started the team forming. This was already very distributed and diverse grouping. Then we had 20 mentors that we could assign to teams. They started preparing the components on November 8th. And the hackathon was then finally here in Doha started with hackathon reception, which was optional and always set a zone for a collaborative environment. A lot of people came and had really good conversations and bonded. And hackathon then happened on the 7th and the 8th. Judging was yesterday, and today they will actually give you some of the selected projects. So these are the projects that happened during this time. And I don't want to read all of them, but the boxes here indicate which presentations you will see today. They were selected by the 3 judges that came. You can see the judges here. Asina, oops. Oh, what happened here? Okay. Asina, Petro, and then Ahmed, right? The other mic is working? Good. Just a little outline here. So this is how the hackathon started with the reception. We had the volunteers helping to hand out badges and with the technical setups. And then you can see actually during the hackathon we had 3 wonderful question answering sessions. One from Paola, which got a lot of good questions and a lot of energy. Shinji and Mirko. And yeah, people worked hard for more than 24 hours during the night. Judging happened, and everybody actually was quite happy because it was so collaborative. Okay, let's nevertheless, if you have judges, you have some awards, and the first award goes to Akash Sasi Kumar, Bokang Chia, Gokul Kartik Kumar for the best potential big idea of Autodub. Can you come up? So you will see the presentation and demo after we went through all the recognitions. The next recognition is Fabienne Nikolaich, Hubert Matusewski, Veronica Valente, and Masa Bali for the craziest big idea, commentator voice synthesizer. Okay, Masa is. Don't walk too far. Okay, so the next project, and they're really all winners in that sense that they got something going, was the best demo implementation by Ashish Ses, Mudit Batra, Arun Kumar R, Seyan Ghosh, Runda, Sukadia, Vasista Sai Lodagala, for Shravan, building multilingual ASR for Indian languages. Can you come? Okay. Okay, and last, not least, Satvik Udupa, Sarah Kumar, Srinivasa Rakhavan, Mek Makavana, Sumi Maiti, Manushta KE for the best hackathon project, dialectical speech recognition for 2 Indian languages, Bengali and Bhojpuri. Okay. So in this case, we actually start the presentation of the projects. So we switch to. Yeah. Okay. Oh, sorry. So we plan to have all the presentations one after the other, and you can ask questions at the end of all the presentations just to keep things moving and keep time. Thank you.
All right. Thank you for coming to this presentation. I'm Bo Kang. With me is Gokul, my teammate, and joining with us remotely is Akash. So we'll be presenting our project in the hackathon, which is called Autodub, a video dubbing platform. Now you might be asking, what is our motivation for this? Well, as we browse the internet, we realize that the majority of content, and not just content, but educational content, are localized in English. However, if you look at the chart over here, a vast majority of the world's population do not speak English and do not speak it natively. And so if we want to bring access to education all across the world, then it's extremely important to localize these language videos in the native language of all these people. Now, the traditional method is human dubbing, which, as you know, is very expensive and difficult to localize all this content. And while there are some online platforms that we have found that uses end-to-end AI dubbing, it suffers from many problems. One such one we found is Dubverse. So here, when there are multiple steps for online AI dubbing, each error that occurs in each step is compounded. So for example, the speech recognition, the machine translation, and the text-to-speech. And furthermore, there are synchronization issues. So in video dubbing, not only do you have to convert the speech, but you also have to match it to the video frames. And so that is very difficult to do with current systems. And furthermore, there are some style challenges. And so we hope that with Autodub, we can create a world that is free from all these language barriers, which can unlock a lot of opportunities. So how does Autodub do it? Well, it's an online video dubbing platform that the key selling point here is human in the loop interaction. So we built a platform that can utilize humans in addition to state-of-the-art machine learning technologies to effectively dub videos. Now here we have transcription, which is ASR, translation, machine translation, voiceover, and some additional features we developed, which ties all of this together. Not only did we build this platform, we also did research some of the latest cutting edge models, which we have implemented and researched, and we currently support these languages. All right. So I'll briefly go over how it works, but we'll show a demo in a second. So you just upload your video, you run through each individual steps. So you transcribe, you make little edits as necessary, you translate, do voiceover, etc., and export it. This is the interface we developed to make it easy to use. So what is the unique selling point between this and other methods? Well, actually, we developed the platform to be model agnostic. So you can switch any of the cutting edge research, even the ones we've seen today in this room, and adapt it to each component in the model, which means that it can be at the latest cutting edge techniques. And furthermore, with our human in the loop, we prevent the error cascading problem. We resolve the synchronization problem, and we hope to collect data through this in order to build a data set that can further enhance this product. Yeah, and background audio extraction is a technique we found was very effective, which I'll talk about in a second. So yeah, these are the technologies. So for the transcription API, we integrated two systems. The first one we found was Whispers ASR for English, which, as you guys all know, is extremely effective. This can also be fine-tuned to other languages, which we are currently investigating for Arabic and Indian languages. Then the translation API, we utilize the state-of-the-art methods in NLB machine translation for all English language to any other language. And for remainder ones, we utilize some commercial techniques. For the voiceover API, we developed this ourselves. Actually, my teammate here, Gokul, led a development team for Indic TTS for Indian languages for 13 low resource languages, which is currently the state of the art that we have integrated in the project. And finally, we noticed the background noise separation problem, which is that text-to-speech does not contain the original video's sounds. So for example, the music, the sound effects that are critical to understanding educational videos. We found that if we take a music instrument separation model and we adapted it, it is actually extremely effective for this particular problem, as you'll see. So this is our timeline that we worked on it. And so in summary, with this platform, we hope that by open sourcing it and having it available to everyone, we can increase educational accessibility, increase the reach of content creators, and make the world have less barriers. And my teammate here will show you a demo of the project. Yep.
So let us imagine a person, Rashid. He has this informational video about Abu Dhabi. He wants to translate this video to Arabic. He could be the content creator. He could be the YouTube consumer. All he need is just a user account in our website, autodub.io. So he could just create an account, log in, upload a video, and follow these process. So first, I have already uploaded and generated the subtitles because it could take a minute. So not to save the time, I've already generated it. So the user will also sometimes the user also has access to the subtitles. So we also support that. So if we have the subtitles already, so all you have to is just to import it. So here I'm importing the subtitles and the generated subtitles got replaced. And this also, we also support the user edits because sometimes the automatic subtitles are not perfect. So the user may want to edit. So we also support that here. For example, here I replace Abu Dhabi with Dubai. And the next step is the translation. So here I'm selecting Arabic and translating. Cool. Now the translation is done. Then the next step is voiceover. So this could take like 30 seconds of time. So in the meantime, like I'll tell you like what is happening. So what we do is we synthesize the speech for each subtitle individually. But the problem there is usually when you do the text to speech, the target length doesn't match the source length. So what we do initially is we adjust the time period to match the source time frame. But so I'll play it here.
عاصمة الأمة وهي بمثابة المركز الإداري للبلد بأكمله وعادة ما تطغى عليها أكبر مدينة شقيقة دبي وإذا كنت
So you could have noticed, so when it plays this particular subtitle, it was very fast. So you could also use this initial output, but what you could do is you could just like edit the subtitles. For example, I could rephrase this subtitle in a shorter way, just like how they do it when dubbing movies. I'll show it here. So I just started learning Arabic, so I don't know Arabic, so I'm just like removing some content. So now I'm regenerating it. So now it came back to normal speed.
وعادة ما تطغى عليها أكبر.
So likewise, the user just have to go through all the individual subtitles. So based on this information here, if it is fast, they can either shorten the text or lengthen the time. Or if it is slow, they could like either add more text, make it longer, or shorten the time frame as well. I'll show here. So now I have reduced the time frame and regenerating it. So now it again
لكن ما ليس بحجم دبي.
it again came back to normal. So once we do all these edits, so the user just has to click voiceover again. Now it will generate the final audio. And one good thing is it also extracts the non-vocal sounds from the source video and combines it with the target video so that the text-to-speech doesn't sound like monotonous.
لكن ما ليس بحجم دبي أو مشهورة مثل دبي. هناك بالتأكيد الكثير من الأشياء التي تسير من أجلها. لذا اسمحوا لي أن أيكم.
That's it. Thank you. Questions? Yeah. Any questions?
The questions I did have. Let's come back when. Masa. No. Yeah.
Hello, everyone. My name is Masa, and today I'm going to present Commentator Voice Synthesizer. My teammates are Fabien, Hubert, Veronica, and mentored by Professor Cheng. Okay. So the main motivation is that there is a very high growth in the gaming industry, which is projected to reach in 2023 $221 billion. And actually, there is a very huge problem. Audio engineers and studios, they say that they have to hire voice actors to record thousands of variations for example, creating a video game like FIFA. So this process is very demanding, and this costs time, money, and effort. So for that, we created a solution. The solution is to create a speech generator. Also, this generates not only the speech, also the crowd noise for a football commentator in order to make the game more engaging. So the project pipeline, we went through many components. The first one is the data collection, transcriptions, and segmentation and text-to-speech. So the first one, we've collected data from YouTube, like 1.5 hours for a football game, for a very famous commentator. He's Tunisian, his name is Isam Shawali. So we crawled the data using YouTube DL. And then the data was without transcription. So we already had a large pre-trained ASR model. We used this model in order to get the transcriptions. And then the words that we also had another round just to check the words that are wrong, and we changed them. And the next step was to vowelize our text using Farasa API. And then we segmented, now for the segmentation process, so we had to segment using, first of all, voice analysis detector, which is a pre-trained model, CNN pre-trained model, that segments the data and produces the label for each segment. If this segment is noisy, or there's a music, or there's silence. So we had to remove all these labels, these segments, and we kept only the ones with a pure speech, with a little background noise, with a little crowd. And the second step was to segment the data, each segment to its corresponding label. So for example, we had 3 different classes: neutral, excited, and very excited. So each segment contains only one emotion, one label. So, and the third step, we had to align our transcriptions with the audio. So for better alignment, we used the CTC segmentation on our pre-trained ASR Arabic model using our Arabic model. And now for the text-to-speech, we used WITS, which is a text-to-waveform model that adopts conditional variational autoencoder with normalizing flows and GAN-based optimizations. So we already before had a pre-trained Arabic model on 1 hour of data. We used that model to fine-tune it on our commentator data, which was 15 minutes. So the input is the vowelized text that we fed to the WITS, and the output is the waveform. And now I'll show you the demo. I'll show you 2 videos. Same video, but one of them a generated speech using our model, and the second one is the real one. So let's see if you're going to guess. So can you please play the first one?
خطيرة وكرة ممكنة ورصيدة ممتازة.
So, and for the second one.
خطيرة وكرة ممكنة ورصيدة ممتازة. الكرة ملعوبة والثالث الحارس. يمشي بطل خطيرة البطولة شيء.
So, did you guess which one is the generated and which one is the? Any guesses?
Put your hands up for one.
Okay, this is easy. It's the real one or the generated?
Oh yeah, put your hands up if the first one is real. Okay, put your hands up if the second one is real.
Okay, so actually, the second one is the real one, and the first one is the generated. Okay, so can you go to the other side? So actually, the limitations and the challenges.
الكورة ملعوبة.
The last slide, please. No, the last slide.
Ah,
Okay. So actually, there are a couple of limitations in this system for sure because we only built it in 24 hours. So there is inconsistency in the pitch of the player's name. So if it's a bit hard to recognize that in the first video, it's hard to say, for example, the name of the player in a certain because it should be said in a specific pitch. So it's like Messi, 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 Messi. You know. So there are many pitches, which makes it hard for the text to speech in this current situation to predict it. And also the segments that we had from the 1.5 hours, there were many noisy data. So this is, and also annotating the data according to the label, which is excited and very excited, is also very hard task to say that this is very excited or neutral. And the last thing that the transcription was not very inconsistent because the commentator speaks Tunisian and he speaks like a couple of French words, like for example Argentina and then Argentina, and you know. So there are many challenges that could be solved in the future. And thank you for listening.
Good afternoon. We'll be presenting our work we have done as part of the hackathon. We have titled it Shravan. We have worked on building multilingual automatic speech recognition systems for Indian languages. Our teammates are Ashish, Mudit, Arun, Shreyan, Vrinda, and myself, Vasishta. We work at Speech Lab at IIT Madras, headed by Professor Umesh. And for the hackathon, we had a mentor, Brian Yan. So coming to the title, Shravan in literal sense in Sanskrit means to listen. So all that we want our automatic speech recognition systems to do is listen well. So if that is taken care of, then we can use the output of the ASR in various applied tasks. So India as a country presents a lot of opportunities as well as challenges when coming to developing ASR systems or any other speech technologies. Given the diversity of languages available, dialects in the different languages available, and as we move across the country, about every 60 kilometers, you will see a change in dialect, and every few hundred kilometers, you will see a change in language. So given this setting, developing speech technologies for the Indian population is a challenge, and also it's an opportunity for people who are interested in it. So our motivation is to bring a social impact. For example, we are using energy to power up the GPUs and generate some models. But at the end of the day, if they are not put to good use, all that we are wasting is the resources of this world only. So we are looking to impact areas like education, Medicare, customer care, and all sorts of entertainment. So as a part of this work, we have tried to develop a pipeline, a video-to-video pipeline and a speech-to-speech pipeline. Essentially, let's say, though we are standing on the same stage here, Vrinda speaks a different language. Her mother tongue is Gujarati, and I speak Telugu. So though we are from the same country and from the same lab, it's difficult for us to converse in a language other than English. So in cases such as this or many other applications we see, speech-to-speech is a game changer, essentially. So as a part of this work, we have proposed a speech-to-speech pipeline. So for example, let's say the user starts speaking in English. We would first like to identify the language that the person has spoken through a spoken language ID. we have fine-tuned the model, voxlingual model built over speech brain and fine-tuned it towards the Indian languages. And then for the ASR, we have built several models ranging from the conformer models built using the ASP.NET framework. Also, we have pre-trained a data to wake model on about 12,000 hours of Indian language data. We'll be releasing that model soon. Also, we have fine-tuned the Whisper model uh, released by OpenAI last year, and we have fine-tuned it over 5 different Indian languages. So once the ASR output is obtained, we pass it through a punctuation model, because without punctuations, going for the machine translation would not be a right thing to do, because it left any error in the ASR stage would get cascaded till the TTS stage. So we would like to ensure that the punctuations are inserted in the right places. So once the punctuation is done, a language ID is also performed over the text that has been punctuated. And once we detect the language, source language, we are using models from Meta, the NLLB models released last year. We have fine-tuned them towards a few Indian languages, but that's towards the technical domain. So for a general purpose, we are directly using the NLLB models released by Meta AI. And once we get the target language text, we pass them through the TTS models developed by SMT lab at IIT Madras. This is the lab headed by Professor Hema. And once we get the target output, we use that to interpolate over the source video, and we generate the video of the target. So this is the entire speech-to-speech pipeline. So as a part of it, as a part of building the ASR systems, we have used several datasets which are publicly available. And this is a list of datasets used for the different languages. So as of now, these are the languages which have significant amount of data, over 1,000 hours per language, put together all the datasets. So we could develop, we could fine-tune the Whisper models efficiently over these datasets. So these are the results on the floor test set of our ASR models. We noticed that directly decoding with the standard Whisper model doesn't result in a good performance. We see WRs over 100. So once we have fine-tuned the Whisper models, we noticed that our models outperform the models released from Google and Microsoft, which are in the public domain. So for Gujarati and Hindi, these are the results. So we notice the ESP.NET conformer model and the Whisper fine-tuning model are the ones developed by our lab. Following the same trend continues with languages like Kannada, Tamil, and Telugu as well. The Whisper fine-tuned model seems to outperform the models from various other, whatever is in the public domain. So as a part of this work, because we wanted to contribute to the open source, we have released all the models, all the Whisper fine-tuned models over Hugging Face, and we noticed significant downloads over the last few days by the Indian diaspora. The challenges we faced while building these models is the agglutination issues present in the Indian languages. For example, the same set of two words can be clubbed together or put apart, but when put apart, it will affect the WR computation. So WR might not be the only metric to look at when comparing ASR systems for Indian languages. And then the next issue is the punctuation marking. So if the punctuations are not marked in the right place, like I said, it could lead to cascade errors in the machine translation and the text-to-speech stage. As a part of a future work, what we would like to do is reduce the interdependencies. For example, we are moving from speech to the text in source language, and then moving from the text in source language to the text in the target language. Instead, if we have a speech-to-text system, which a speech-to-text translation system, which gives, for example, if I speak in Hindi and the output comes out in Tamil, directly we can use the text output to feed the TTS model and generate the target speech. That is one of the areas we are looking at. And the other area we would like to focus on is building diffusion-based TTS models, because those seem to be giving better, more naturalness to the voice. So the resources that were used for this work were funded by the National Language Translation Mission, funded by the Ministry of Electronics and Information Technology, Government of India. So right now we'll be showing a demo of our video to video. Vrinda will be demonstrating a demo from English to Gujarati and English to Hindi. We are, as I mentioned earlier, we are using the translation option as the NLLB model from Meta AI. Thank you. So as we can see, there are several languages available for the ASR, ranging from English up to Telugu. These are the Whisper models, Marathi being the conformer model in the whole pipeline.
Yeah, so we can select the target model, target audio language for this demo. So I'm selecting it Hindi, and we are selecting machine translation model from Meta AI and voice, female voice. Hello, we are working on Indian languages. We hope this will benefit Indian society.
So being a cascade system, we run ASR once, the machine translation next, followed by TTS, and we interpolate the video based on the segments generated.
भारतीय भाषाओं पर काम करने से हमें उम्मीद है कि इससे भारतीय समाज को लाभ होगा.
So let me play it again.
भारतीय भाषाओं पर काम करने से हमें उम्मीद है कि इससे भारतीय समाज को लाभ होगा.
So this is the video to video pipeline. The way the target video gets generated is once we have the VAD generated segments, the voice activity detection based segments, we use the timestamps from there to stitch back together the target video. Also, we have, sorry. Also, we have this is the demo link for video to video. People can try it out. There are also speech-to-speech pipelines and the ASR to machine translation pipeline available. So Vrinda will now be demonstrating another from English to probably Gujarati.
Hello, we are working on Indian languages. We hope this will benefit the Indian society.
ભારતીય ભાષાઓ પર અમને આશા છે કે આનાથી ભારતીય સમાજને લાભ થશે.
Yeah, thank you.
We had some technical problems at the beginning with the microphone setup, so that's the reason why it started later. Oh, how do you actually? You better start it.
It's not.
Okay, hi everyone. So this is going to be what we did for the hackathon. That is, dialectal speech transcription in Indian languages. And for our team, we had, Srinivas, Meg, Saumi, as well as Manjunath. And this is Saurabh, and I am Satvik. And we were advised by Jota. So in our hackathon, we are mainly looking at building a multi-dialect speech recognition system in two different Indian languages, that is Bengali and Bhojpuri. So what's the main motivation behind this? Well, if you look at a country like India, right, which has a large population but low literacy rates, but also recently a high, degree of digital adaptation, this combination kind of make it ideal for voice interfaces to be integrated into services and products. But in reality, there's a lot of challenges that occur. Now, also, some of you may already know this, and also, the previous presentation, they already mentioned this. India is a very diverse country when it comes to language. There's so many languages, and each language has so many dialects. And also, the thing is, it's kind of hard to define what exactly a dialect is and to quantify this in some sense. Because as you keep going from region to region, a lot of things keep changing, speaking style, vocabulary, etc. Just speaking from my own personal experience, my native language is Tulu, which is a very low resource language. And also the local language that I've been learning is Kannada. And, through my schooling, I've been at different places. So if you ask what's my Kannada dialect right now, I don't know what to answer. Right? So there's a lot of different challenges which arise in this scenario. So for the question that you have to ask is, what can be done to, kind of handle all these variations in the data? So the one thing is that you actually need, data sets which can, handle speech recognition in all these different dialects, and also see if you can, build specific models which can handle these dialectual variations well in the data. So now if you look at, the data sets available for speech recognition in many such Indian languages, it could be, Bhojpuri, Maithili, Maghai, Chhattisgarhi, etc. There's not much data available. And even specifically, we don't really have any dialect specific data. And only recently there has been, significant data being coming in. For example, it could be the CSTD Telugu corpus from, IIIT Hyderabad. So of course, more such work is needed so that we can, make collective progress in this area. So this is where the Respin project comes in that we are working with from the data that we have. And it's been headed by Dr. Prasanta Kumar Ghosh at Spire Lab, IAC, along a collaboration with Navanatech. And it has been funded by Bill and Melinda Gates Foundation. And we have been using the data set of Bengali and Bhojpuri, which has been collected as part of this project. So for Bengali, we have 5 different dialects, and Bhojpuri identified 3 different dialects. And if you look at the duration, for Bengali, we have around 1,200 hours, and Bhojpuri, we have 1,100 hours. And again, we are kind of showcasing these statistics of our data sets and kind of showcasing that it's the speakers, prompts, utterances, durations, they're all balanced across different dialects. Okay, so the first thing that we have this data to work with. Now we want to understand how do the existing pre-trained models perform against these dialectual data sets. So we'll mainly consider 3 different models. One is the Google Cloud speech recognition API. Then we have the Whisper Large, which is the V1 version, and also a Vakchance, which is another popular pre-trained model in Indian languages. And of course, for Bhojpuri, we used a Hindi pre-trained model because we didn't really find a well-performing Bhojpuri ASR. And also for Bengali, we have used the same type of models. So as you can see across all these comparisons, the word error rate is, the best possible is around 41, right? So there's a lot of improvement that can be made in these areas. So let's look at what exactly that we did as part of the hackathon. Now, the main thing that we kind of wanted to look at is, what sort of learning methodologies could work well, in these multi-dialect scenarios. So towards that, we wanted to try out, different frameworks and different learning methods. So, we have the TDNN results from Kaldi, which kind of uses like a phonetic dictionary on the whole corpus that we have developed. And we have the results for that. And the best performance from that is, around 19 WR. And again, ESPNet, again, we tried a lot of different configurations, mainly with, conformer, transformer, and attention plus CTC type models. And again, in this case, we kind of obtained the best performance for Bengali with a custom architecture where we use, like a multiple encoder setup with some scoring function with the intuition that, these kind of architecture could work well when there's variations in the data. And also we tried other different strategies. We used, XLSR models, fine-tuning it with the Hugging Face code base. And also we tried various NEMO models as well. And we got the best performance for Bhojpuri with the conformer RNLT from NEMO. Now, along with this, we also did various ablation studies as well. We were kind of interested in looking at the variations of results across different dialects. This involved training different dialect-specific models, decoding it in particular configuration, etc. So there's a lot of insights from these experiments as well. So yeah, so we did the same experiments in Bhojpuri as well. Now, mainly to give a summary of our results, we tried a lot of different methods, and in particular, we discovered that some kind of architecture could work well for a multi-dialect scenario, and also there's a lot more to be done, in incorporating self-supervised learning features or whisper kind of features. So of course, there's a lot more work to be done. Now it's over to Saurabh, who's going to mainly talk about the practical applicability after what we do after this training these ASR models.
So consider this example of Lakshmi. It is a true example. We came across her through our data collection process. She is a semi-literate woman from a remote location in Kharagpur, India. And she can fluently speak Bengali, but not being able to read or write. She basically represents a significant part of Indian population who has access to all the smartphones, and they use voice messages on a regular basis to interact on social media platforms such as WhatsApp. But they still travel to bank for like 40 to 45 minutes and stand there in long queue just to get something as simple information as knowing their bank account balance or printing bank statement. But with the reliable speech technology available in their mother tongue, they could easily interact with it on a digital platform using their own voice and get those information quickly. So to demonstrate that application, we created a WhatsApp bot. We have a demo for which here. So we have the QR code. If you want to try, you can scan and try it out.
Here is a demo. একটা জন কলার দাম কত? টমেটো চারা কোথায় পাবো?
So this will basically transcribe multiple Bengali sentences from agriculture and finance domain.
Now I'm going to try few banking domain sentences. স্বাস্থ্য বীমার কি কি সুবিধা আছে? কন্যাশ্রী পেতে গেলে কি কি করতে হবে?
In addition to that, we also, for a more real-time application, we also tried implementing a streaming ASR model setup, for which we used NVIDIA NeMo model, which was shown earlier, and it was hosted on a AWS platform. For that, we also have a demo here.
ঠিক মনে করতে পারছি না, একটা কথা যে শরীর এমন একটা জিনিস যা শোয়াবে তাই সব। আর আমি মনে করি সচিন তেন্ডুলকার শরীরের নাম মহাশয়, হ্যাঁ শরীরের নাম মহাশয়, যা শোয়াবে তাই সব। সচিন তেন্ডুলকার এমনই একটা মানুষ, সে এক্সেপশনাল না হলে এই জায়গায় পৌঁছয় না। 100টা 100 করা ইজ আনবিলিভেবল অ্যাচিভমেন্ট। অতীন ধরে
Yeah, so that was it. That was it for the demos. So all of these models are publicly available. We have the QR codes which you can scan and use with your own WhatsApp. And also the streaming models are available at the link. Again, you can scan the QR code for that. So you can try that out. And for all the results, you can visit our website. And also we have linked up all the tutorials, etc. And also if you're interested in the data set and the pre-trained models, we will be releasing that at some point in the coming months. Thank you.
Okay, for the sake of time, we cannot have a question answering session. However, those guys are around, so maybe after the next keynote, you can look for them and ask them questions. So please give everybody who participated in the hackathon another hand, and then let's do session. This is our laptop, right? You take care of that.
Thank you. The hackathon was great success, and thank you very much for introducing the hackathon for the first time in IEEE. I'm sure you have managed to take lots of pictures. You are free to take more pictures and enjoy the rest of the day with us at SLT. So we now are happy to have adapter. Right. So we ran a little bit over time. But that's because the SLT hackathon was exciting, and we have lots of very interesting projects. We are happy to have with us Preslav Nakov. He is now grabbing his adapter and will be on the stage in a second. So yes, we're happy to get that adapter out. Okay. Before there was an adapter.
So
Good. So Prislav is a professor at Mohammed bin Zayed University. He's also the deputy director of the Department of the NLP. Before joining Mohammed bin Zayed University, Prislav used to work as a full professor, principal scientist at Qatar Computing Research Institute. He led many projects. One of them was the most exciting and well known for is fighting the fake information, fighting the fake news and disinformation. His research has been featured in many places. It was very interesting, and the exact time it has been featured in more than 100 outlet news rather than the interesting research that came out of it. He got his PhD from University of Berkeley. Interesting fact that I have been enjoying working with Prislav for many years. We have great time together, and we are happy to have him back in Doha to give us interesting work about what he has been up to and his vision on the multimodal disinformation. We ran a little bit over time with 10 minutes, but it's okay. We can take 10 minutes from the next session. So Prislav.
Okay, can you guys hear me? Oh, good. Okay. Yeah, thanks, Ahmed, for the nice introduction. It's good to be back home. So let me start with, so I'm going to talk about multimodal fake news detection, but I also take this opportunity to cover the different sets of problems related to disinformation, right? So, I mean, when you talk to fake news, people start immediately think of fact checking. Okay, we're going to go and fact check, and there has been a lot of effort into that. The question is, how much has been fact checked? If you look into Duke Reporter Swap, they have a list of the different kinds of initiatives related to fact-checking, and they are actually certifying fact-checking organizations. And there are over about 200 active projects and some inactive, and you might think that's quite a lot. But then kind of if you zoom and you look into how much was actually fact-checked, you see a little bit different picture. So it's a little bit outdated, but the numbers are roughly correct. So you see Snoops, PolitiFact, they have 10,000, 20,000 claims fact-checked, but everybody else just a few hundred, because checking a claim takes a day or two, sometimes, a week. And it's really the capacity of many fact-checking organizations is one claim per day, sometimes two. Okay, so it's really a lot of effort. And if you look into other kinds of scales, so for example, the claim review schema, which aggregates fact checks by different organizations, there are 77,000 claims. Okay, the Twitter Birdwatch program, which is kind of crowdsourcing the fact checking, they have 12,000 claims that have enough fact checks to be usable, right? So it's not that much. And then the question is, what can you do with technology? Well, you can do two things. And if I do, you can make fact checkers more productive, or you can automate the entire process. And again, the vast majority of research has been looking into, let's go automate the entire process, and less attention has been paid into what actually journalists and what fact checkers need. And I can make parallel to translation technology. So there's full translation, something like, kind of the tools that you normally use, and some of those have been here shown in the hackathon. And there's also tools like translation memories that are making the human translators more productive, right? And there's the need and the internal development of similar kind of technology to help the fact checkers. The question is, what do fact checkers want? So we had a round table, some 2-3 years ago, where we invited fact checkers from leading organizations, and here's what they told us. Well, number one, you want to know what is the most important claim to fact check today. Number two, you want to know if somebody says something that was previously fact-checked, because you don't want to fact-check it again, or maybe you want to monitor after you have fact-checked it whether politicians keep repeating it. Then you might want to approach them and say, why are you saying this? Okay, or maybe something was, and so on and so forth. And then you want to to make their job fast, right, so that they can do it easier. And actually, many fact-check organizations are developing tools for those three tasks. Okay, but and as you see, they don't really want something to replace them. They don't want necessarily the fully automatic process, right? They want something that is going to facilitate their job. And I'm going first to talk about those two problems, and then I'm going to go to the actual fact checking. So we have been running the Check That WAP, which has been focusing on the full pipeline. So the first pipeline is, okay, let's like find what are interesting claims to fact check. The second one is, was it fact checked before? The third one is, let's kind of get the relevant evidence. And the third one is actually, let's do the fact checking. And then there's fact checking, there's fake news detection. What's the difference? Fact checking is about a claim. Fake news detection is about an entire article, right? And there are also other levels that I'm going to talk about. I'm going to be talking about profiling entire news outlets and also kind of characterizing entire communities. Okay, and we have been doing this in different languages, right? And I'm kind of proud that we have been like promoting those tasks, and we have been doing this in social media and also in political debates. Okay, so what is worth fact checking? Well, the first thing is you might want to do something that kind of spots the interesting claims, and you might want to have not just the claim, but also who is saying them, what is the topic, what is the stance, and so on and so forth. We had kind of like a recent paper on that. I don't want to go in much detail, but kind of if you want to do something that is detecting the interesting claims in a political debate. So imagine a debate just finished, okay? The capacity normally is to check one claim per day, okay? Imagine that now you have assembled a bunch of fact checkers, of journalists, and you are ready after the debate has finished to fact check maybe 10 claims, maybe 20 claims, okay? And you want to do it immediately after the debate, okay? Or maybe even during the debate. The question is, what are the claims that you're going to focus on? There are 1,300 claims, not even claims, sentences. Some sentences have more than one debate, more than one claim. In a debate, you have on average 1,300 sentences, okay? What are you going to prioritize? Okay, and you want to act fast. You want to publish this very, very fast, even potentially in real time, right? So, and well, what can you do? There has been different attempts to this, but actually you can learn from human fact checkers because they have been doing this for years. And you can see what are the claims that they have selected to fact check, right? And you might want to learn from this and try to imitate them. And then you can put different kinds of observations, different kinds of features, different kinds of embeddings. You can see whether name entities are there, you know, something about the discourse structure and so on and so forth. And you can do this kind of at the text level. You can also do kind of put there the speech signal, and you can try to see whether kind of there's some information coming from the speech. And you can learn from different fact check organizations because after a political debate has finished, you have different kind of New York Times, CNN, and so on, in addition to PolitiFact, FactCheck.org, and so on, kind of, they are all doing the fact checks, and you can actually kind of try to learn from all of these. And we had a system for this that actually works for English, for Arabic, and you can even kind of say, I want to imitate the fact-checking decisions of a specific fact-checking organizations, because it turns out that out of 9 organizations, there was only one claim that was fact-checked by all 9, right? So kind of there's also some subjectivity involved in that. We have been looking into to what extent the speech signal can help for that, right? To spot what is interesting to fact check. And we have some interesting results, but kind of that's not conclusive. I'm just telling you it's an interesting kind of direction. And if you have ideas, you know, let me know. Yes. And so well, another aspect is actually that it's not just text, right? And if we have tweets, and you might have there also images and so on. And here, for example, this kind of a different kind of multimodality, right? Not the speech, but the image. So here's a claim, okay, well, because media are not going to collect this, you know, this kind of a tweet by Eric Trump. Here's a check that Donald Trump has been donating his salary to fight the coronavirus. By the way, do you think this is true? Okay. Well, actually, it is true. Okay, it was fact checked. Okay, it is true. But here the point is not whether it's true or not. The point is that this is something interesting to fact check, and I guess you would agree, right? There are many tweets on the web, but this is something that you might want to spot, right? When it's tweeted, you want this kind of to come. The question is, what makes a claim check-worthy? And we keep looking into the literature, and we came up with certain criteria. And one of them is, well, it should be popular, kind of should be viral, or should have the potential to become viral. Should contain a claim and a verifiable claim. If there is no claim, there is nothing to fact check. Should be likely to be false, otherwise why do we bother? Should be likely to be harmful, should be of public interest. And then based on this, basically we came in asking people to answer all these questions and finally to tell us whether this is kind of something interesting to fact check or not. And what is interesting is that when you decompose the problem into those components, and if you try to do multitask learning, you try to predict not only whether it's interesting to fact check this claim, but kind of you also try to predict whether it's likely to be false, whether it's likely to be harmful, whether it's of public interest, whether it's kind of likely to become, you know, actually you weren't better. So here, for example, you see that if you do single kind of one task learning just for check worthiness, this is where you are, and multitask learning kind of, it helps you quite a lot, right? Yeah, we had built at the time of COVID-19 some tools for this that actually works in different languages. So it supports Arabic, English, Dutch, Bulgarian, and frankly, kind of we have data for all these languages that are here. So there's also Turkish, there's Spanish, and so on. By the way, for Spanish, we have very good data because it's coming from actual fact-checking organization from neutral, the only one in Spain. Okay, and for the others, we have like doing our own pages. So now let me, and then kind of there's another aspect of multimodality. I have already mentioned that, and we are having that in the upcoming CLEF Check That lab, which is about kind of detecting whether a tweet is check-worthy, and this is focusing on tweets that actually have images. So this one on the left is not really check-worthy, and this one here is actually check-worthy, right? And so there's something that is kind of in the text, but it's also something that is in the image. Okay, detecting previously fact-checked claims, checking whether something was fact-checked before. The problem with kind of automatic fact-checking is that people don't really trust that much this technology because they don't know how the system came up with the solution. So imagine that you are, for example, you're interviewing a politician, okay? And you say, Mr. President, I have an AI learning on my phone, and you just told me that you are 95% likely to be lying right now. Can you please elaborate why are you lying? Okay, and this is something that you can do. I mean, speech recognition you can do in real time. Some kind of automatic fact checking you can do in real time. The question is, can you do that? No. Why? Well, because you don't know how it came up with this solution, right? However, imagine that this device actually tells you, look, he just said something, and he is a previously fact-checked claim by an organization that you trust, and here's what he said, and here's what was fact-checked. I can even like scroll quickly and see, the kind of what is going on, and I can put him on the spot and say, look, this is not true, kind of you said that you never voted for blah, but actually you voted 6 times or whatever, right? And this is something that can potentially revolutionize journalism, right? And this is something that puts together speech technology with kind of automatic fact-checking, but also using all the effort that has been done so far. And over time, a lot of claims have been already kind of fact-checked. And this is an interesting way of machine kind of human collaboration. And you can do this during a political debate, right? And we have been kind of working on this kind of technology, mostly on the text side, right? But obviously, putting this together with speech is something that is doing it real time. And there have been some similar kinds of systems. So this is not an easy task. I mean, obviously, you know that the speech signal, what comes as automatic speech recognition, the text is not necessarily coherent and so on and so forth, but there are many, many other things. There are actually pronouns and so on. So for example, here the claim is, I waited that it had actually been, negotiated because I did want to give the benefit of the doubt to the administration. And if it just, this is something that was fact-checked, okay? But if just looking into this claim, it's not clear even what this is about. And if you want to understand the context, and then if you want to match this against a collection of previously fact-checked claims, it's not just about matching against the claim, it's matching against the entire document. So kind of you need to reason there, you might want to have some kind of graph structure and so on and so forth. And you might want to do this kind of in the context of a document. So, okay, now after seeing that, obviously the manual fact-checking cannot really scale. Even if you help human fact-checkers, there's not that much. I mean, if their speed normally is like 1 claim per day, maybe you can make them work with 2 or 3 or 5 or 10 claims per day. I don't think 10. So the question is, maybe automatic fact-checking is a solution to this information, right? And there has been a lot of work on that. And actually, we have done some work on this, where it's again kind of in the context of political debates, and you want to check kind of, normally the claims are out of context. So you have the claim, and the claim is somehow kind of massaged, and it's very nice and all that, but I have shown you kind of this Okay, well, he approved NAFTA. Okay, those are kind of more or less kind of self-contained claims, but not everything is like that, right? I have shown here, right? And here the task is, okay, I give you the text of the debate, or also I give you the speech signal, and you want to tell me whether something is true or not, okay? And those are kind of claims that were actually fact-checked, and we have done some work. Actually, Ahmed is a co-worker on this kind of work back in 2019, where you kind of want to do this. And obviously, you can do things like MFCCs. I mean, compare this from Interspeech 2013. They're interesting features, and kind of these days, Look is very interesting lexicon that has manually annotated kind of gazetteers that are very, very useful. And yeah, kind of, we have basically, if you compare this, for example, to BERT, kind of, which is just like the textual or TF-IDF, actually you see that there's a lot of information coming from the speech signal, right? And so kind of in addition to what you actually can get from the data. Of course, kind of the speech community knows there has been a lot of work on kind of deception detection, you know, from the speech signal, but typically in previous work, it has been somehow artificial in the sense that they were asking students to lie or not to lie, okay? And they're kind of doing this, and then that's kind of not natural, right? Kind of, you know that you're lying or you know that you're not lying. Or there was kind of data sets that are looking into court decisions and then kind of the person is convicted or not. If it's convicted, maybe he was lying, but when exactly and so on. So kind of those are the kind of data sets that typically exist. And here we have like real world data that was actually fact-checked by fact checkers, right? So this is something that is interesting. And so fact-checking can be done in different modalities, because here you are talking about modalities. It's not just the text, it's not just the speech, it's not just the images, it's also tables. Okay, there's a lot of information coming from tables, and there are claims about tables saying, I don't know, something about the average and so on and so forth. Wikipedia has been used, and a lot of information. Then there's the graph modality. Okay, there's the social network structure that you want to put there. So, for example, this is a typical fact-checking architecture in social media. So you have the claim, you see how it evolves over time, how the language evolves, you see who is kind of commenting on it, you see whether they agree or disagree with it, you see kind of what they say, then you see if there's a link to kind of to articles. You check whether those articles are fake news or not, who is publishing them, is this a reliable website or not, and kind of you put all this information together, you have kind of this heterogeneous graph, and in this heterogeneous graph you have labels for very few of the nodes. You only know about a small number of articles that they are fake or not, about a small number of websites, and so on and so forth. And basically you try to propagate information and to make a decision based on this heterogeneous graph. And this is something that we have done like 2 years ago. So, and multilinguality, in addition to multimodality, is another thing that is very interesting. So in my view, what is interesting these days is to go into multilinguality, multimodality, and also cross-platform. So kind of you really want to integrate information from many, many different things. And we have been working on creating a multilingual data set of actual claims that have been shared and fact-checked on Facebook. That's kind of from last year. And then crowd checking is a very important direction, because kind of people often say, well, this is not true, and kind of then you need to understand the structure of the conversation, what they're referring to, and whether this is really kind of, they're pointing to a website that is actually has fact check this claim, and you can exploit that. Okay, now, even with automatic fact checking, let me ask the next question. Can we fact check every single claim in the world? Okay, well, there has been a study back in 2018 in Science that shows that false information goes much faster and goes much further compared to real information. And there was actually another, and this is a very famous study. They have taken every single fact check claim on Twitter and have been like studying what happens in the network modality. But there has been another study that is less famous, but I find quite interesting, that shows that 50% of the lifetime spread of some very viral fake news happens in the first 10 minutes. What this means that if it's going to eventually reach, I don't know, 100 million people, the first 50 million are reached in the first 10 minutes, which means that if you want to intervene, you need to act very fast. And the question is, how can you, I mean, this in 10 minutes is not clear how much information you're going to get. You're not going to get, if you look into this picture, you're probably not going to get like entire articles written by somebody, right? I mean, and it's not clear how much reactions you can accumulate. So what can you do? Well, you can do things, and things these days are even worse, right? Because I can generate fake news, right? And this is like GPT-2, or you can this kind of GPT-3, ChatGPT. It has some protection against these. And here the image is automatically generated, the text is automatically generated, and if I actually kind of paste this, in social media, it's like very short, right? And I mean, people immediately kind of, I pasted just to take the snapshot. People immediately said, "Oh, your account is hacked. You're spreading fake news," which is good. But people, even if those generators are not so good, for the first one or two lines, because who is going to click on the link, right? Kind of people just like read the title in the first one or two lines, it's good enough. So you can actually kind of automate the generation, right? Then what this means? Well, you cannot really fact check every single claim because I can also generate them automatically faster than you can check them, right? So what can you do? Well, one thing that you can do is you can actually focus on the source. This is what journalists do. Okay, they ask, are there 2 or 3 reliable sources that are saying this? This is what antivirus programs do, kind of, this is, or computer security and whatever. They're like, is this a domain that I trust, okay, or not? And it is kind of much higher granularity. And I think it's a very good way to go. And there are different initiatives in that direction, right? Kind of like trying to characterize an entire news outlet. And then I say that you can, if you do that, you can fact check the fake news before it was even written. Why? Well, if you just put a claim, you made up a claim and you put it in social media and leave it as this, it self-fact checks very fast if it's not true and if there's not enough evidence, because people say, wait, I don't find information about this anywhere else. Who said so, And basically can I say this is probably not true and it dies very fast, okay? Now, if you want people to believe it, you need to put a link to a website, okay? To a link to a web page. And this web page has to sit on a website. And you cannot create a new fake news website for every single false claim that you are making, okay? You can reuse, you need to reuse. But then if you're using this website, we can actually kind of eventually go into our list of constantly evolving list of, websites. And then next time when something comes, we can actually immediately tell you, well, it's not coming from a reliable source. And so just to give you an idea, so media bias fact check is one of those initiatives, and there are several others. And they are saying, let's say for New York Times, it's high factuality, and also kind of they are telling you about the bias, left, center, right bias, okay? And and there's actually a connection between factuality and bias that I'm going to talk about. Now, if you move to this task of characterizing an entire news outlet, you say, can I trust BBC? Can I trust Fox News? Can I trust, Al Jazeera? Whatever, kind of, you think of a medium, right? Can I trust them? Or what is their bias, left, center, right? And there's a connection between those two. Then this is actually a more interesting and an easier task compared to fact-checking one claim or fact-checking one article, because you can get a lot of information from different sources and also from different modalities, okay? So for example, you can see, okay, what they say, but also kind of what is their social media profile of this news outlet, okay? And we have been also analyzing their YouTube channels. So you go there and you take the video, take the sound, and you see not only what they say, but how they say it, okay? If this news outlet actually has a news channel, you go and you crawl a few thousand audios and you kind of try to do that. Then you see who are the people that are reading it, okay? And whether they agree or disagree and kind of what is their stance on different topics, what is written about them on Wikipedia, and many other things. Things like who is hosting them, what is their security certificate, what is their web tracker, what kind of images they have, what kind of videos they have, and so on and so forth. Kind of, you have like different sources of information, and kind of the network structure is also important, and you kind of combine all that. And just like to give you some idea, the text, obviously, kind of there's a lot of things in the text. Is there a connection between the title and the body? Maybe it's just like clickbait. Is there a lot of emotions? Is there a lot of subjectivity? Is there a lot of repetition? Is it short? Is it long? Because writing fake news is not easy. You are making things up. You are getting repetitive or short, right? It's not so easy. So, and those are things that you can detect automatically. What is there about this website in Wikipedia? Sometimes they say this fake news website or it's good or whatever. You can analyze automatically the text there. What is there about Twitter? How they self-describe? Is there a link to their website? Is it a verified account? And so on and so forth. What is the structure of the URL? If you have like something like, I don't know, 100% fed.com, that's not a serious name, right? And you can analyze actually the language of the URL. You can analyze the web traffic. So you can actually try to analyze the YouTube channels. That's something from interspeech that we have tried at some point. So we have like trying to characterize an entire news outlet based just on the videos that they have in the YouTube channel, right? And then basically you collect a few videos, then kind of try to characterize them one by one, and then somehow aggregate the information and try to come up with an idea about whether, you know, what kind of channel this is. And of course, you have the typical things, I vectors, you know, things from OpenSmile and so on. Again, kind of these days, this is kind of kind of these days you can do other things. This kind of so this is the media bias chart that shows you that the extreme left media, so here the higher you are, the more factual you are, and he's left, he's right. And you see that the extreme left media and the extreme right media tend not to be trustworthy, right? Those that are kind of the most trustworthy kind of ones are typically more balanced, kind of they are not really taking very extreme positions, because if you are very, very extreme, there's nothing wrong with being left or right, okay? But if you are extreme left or extreme right, for you it's much more important to spread your propagandistic message, and kind of the factuality becomes secondary. And then you can locally disagree here and there, but this kind of the general trend, right? And so it actually is a good idea potentially to model jointly the factuality and the bias of news media, and we have like doing that, and actually you can gain something, because in certain cases you are very sure about the factuality but not for the bias, and the other way around, and kind of doing multitask wording, just like I have shown you with the check worthiness, right, actually helps you here. I want to jump into something else, propaganda. So what is propaganda? Well, propaganda is a communication tool that is deliberately designed to influence the opinions and actions of other people in order to achieve a predetermined goal. Now, when it comes to fake news, let me kind of a little bit of terminology about fake news. Fake news is not a good term, because fake news kind of misleads people to only focus on factuality. So people that are working on the topic typically talk about disinformation. What is disinformation? It's something that is both false and kind of has a harmful, kind of has the potential to do harm, okay? So it's the interception of the two. So now propaganda is something that is kind of orthogonal, because whether it's true or false is not part of the definition, and whether it's harmful or not is also not part of the definition. So propaganda can be good, can be bad, can be true, can be false, okay? So it's just like I try to convince you of something and I have a goal in mind. This can be a good goal, okay? And we have been looking into different propaganda techniques. There has been a lot of work. We have been also doing different kinds of work, trying to understand whether this article or this website is kind of propagandistic or not. But it's more interesting actually to understand what is the way that you are being manipulated, kind of what are the specific propaganda techniques that are being used. And those fall in two general categories. Some of them are certain kind of emotional manipulation, and another kind is something looking into logical fallacies, right? Things that don't make sense kind of logically. So you can do that, right? We have been kind of primarily looking into the text level, but recently have been also kind of thinking whether the speech signal actually can help into detecting those, right, propaganda techniques, because maybe when you are trying to convince people, you are changing your voice, right, in a specific way. And so this is the output of kind of, a system. So basically you try to predict for each word where it's part of a spam, propagandistic spam, in addition to this, whether a sentence is propagandistic or not. And you have some kind of gates that are inhibiting or increasing the likelihood. So here you have an article, and here the kind of the propaganda techniques. So mass murder is like loaded language, or you have Anthony Fraudulent Fauci is the king of misinformation. So this is kind of name calling and stuff like that. You have scandemic as a loaded language, is kind of appeal to emotions. Actually, this is something that you can go and you can try. This is the PERTA system. I don't have the link here for whatever reason. And we have been doing this also for Arabic. And more recently, we have been working together with the European Commission to these kind of tasks for multiple languages. So we have like English, we have German, French, Italian, Russian, and Polish. We have 6 different languages, and we have these kinds of annotations. And we have organized a little bit the propaganda techniques, just like to give you an idea. So the first, they are kind of going into different categories. So the first question that you ask is, okay, is it a call or is it a statement? A call is like a slogan or stuff like that. If it's a statement, does it use a manipulative wording, like, I don't know, loaded language emotions, or is it about the argument? Then if it's about the argument, is it attack on reputation? Who is the person who is saying it or something like that? Or is it about the topic? Then if it's about the topic, is it a distraction, like strawman, kind of, trying to shift the topic in a different direction, or is it actually relevant? If it's relevant, if it's simplification, like causal reciprocation, oh, this happened because of that. You have something that happened for maybe 5 different reasons together, but you can focus on only one of them, right? And then if it's to the point, and stuff like this, kind of, we have like 23 different propaganda techniques organized around 6 different things. And this annotation was done in text, but it's really interesting to see to what extent for the detection of propaganda, the speech signal, right, or potentially video signal, kind of other modalities can help. And then you can look into coordination. So this is really about entire communities. So we have looked into tweets during the UK elections, and and the degree of propaganda in those tweets. And kind of coordination is a matter of degree. So I can look into some very, very small core of users that are very, very coordinated, or I can look into a little bit bigger kind of, some users around the core that are also quite coordinated, but a little bit less. And then kind of a little bit bigger community, it's also kind of coordinated, but kind of a little bit even less, right? So I can zoom in and out with coordination, and I can say, okay, let me push to the very, 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 very core. And basically what you expect is that the propaganda is going to go up. It turns out that's the case, but for certain communities, actually it goes down or stays the same or goes down. And those are actually kind of grassroots movements. So it's also kind of another interesting way, looking into the kind of network modality, right, to understand whether kind of this community is kind of grassroots or is actually controlled by somebody with certain purpose. And this was kind of another best paper award last year at website. Memes. Memes are very, very powerful, okay? So if you just tweet something, just text, it doesn't get as far as if you actually have memes, right? And of course, there's a lot of propaganda in memes, a lot of, and we have been working, for example, together with Facebook, Meta, on detecting kind of the propaganda in memes. And so, for example, here we have appeal to fear, black and white fallacy, right? And here we have whataboutism. Those are kind of techniques that you see here. And of course, they can be very, very powerful. Right? I mean, And then you can be asking also, right? I mean, I told you that disinformation, the real term for fake news is actually disinformation, right? This is the term that international organizations like, I don't know, European Commission or NATO, World Health Organization, and so on and so forth are using, and fact checkers, journalists, that they're talking about kind of disinformation, something that is false and means harm. And again, just like the vast majority of the research has been focusing on whether fact-checking, whether something is true or not, the vast and has been ignoring things about what actually fact-checkers want and where it's interesting to fact-check before. The same way, if you think of the definition of disinformation, people have been like focusing only in where it's fact true or not, and have been ignoring the other part where it's actually harmful or not. And we actually kind of looked into that problem, right? And it can be harmful for different reasons. It can be like it's fake news, can be hate speech, can be sarcasm. And you might want to know the degree of harm and who is being targeted. Is it an individual, organization, or society as a whole, right? Who is going to be impacted by that? And of course, you can ask the same questions about the video, kind of, and you can kind of analyze the speech signal and so on. Here we have done it with memes. And you need to analyze the speech modality, the image modality and the text modality and put them together. Another task that is interesting is actually to understand the specific entity that is being targeted, okay? So you have a meme and give you what are the entities that are mentioned there. They can be coming from the text analysis, from net recognition, can be coming from the analysis of the image, right? So kind of maybe, for example, some certain vision APIs are going to tell you what are the entities of certain celebrities mentioned there. And then you need to say which of those are halfway targeting, which not, okay? And we have been working on that. And another extension of this is actually to say, okay, who is portrayed as a hero, as a villain, as a victim, okay? So I have the meme, and we give you the meme, the image, we give you the text, maybe extracted OCR, and we give you the list of the entities. This is also kind of easy to get, and to ask you, who is the hero, the villain, the victim, okay? And I can talk about the same kinds of entities, you know, in different ways, right? And you might also want to know, to generate automatic explanations, okay? So I give you the meme, I give you the entity, I know, tell you what the role is, it's already detected by this system, and I want you to tell me why. And actually, here's what we generate. For example, the Democratic Party is portrayed as being falsely accused of a hoax. That's something that is going to be presented next month, IEEE. Okay, so one thing that I wanted to point to you is that there's an interesting shift these days from fake news to infodemic, and this is going to kind of in terms of terminology, right? So people have been talking initially about fake news, and where's the focus? The focus on whether it's true or not, right? And then people started talking about disinformation. Disinformation is something that is balanced. It's about something that is false, but also something that is potentially harmful. And with the beginning of the pandemic, the World Health Organization started talking about an infodemic. And here the focus is really about whether it's harmful or not, and less about whether it's true or not. And if you think about it, 2016 is when the term fake news was coined. It was regarding the US presidential election 2016. And in 2020, the focus was different. The focus was on kind of hate speech and kind of on the harm, right? So kind of there's this evolution, and this is something that I also kind of wanted to pay attention to. It's not only about factuality, it's also kind of about the potential harm, which is equally important, if not even more. And yeah, this is the term. And actually, immediately after the pandemic was defined, it was declared, the World Health Organization already invented the term infodemic, right? This is something that I have found on their website out immediately after declaring. They had like their top 5 priorities in fighting the pandemic. And you see that number 2 was fighting the infodemic among the top 5. So kind of early on, they realized how important it's going to be. And they put the focus not on factuality, but on the potential harm. So, and this is again something, this is from February 12, 2020, early on, where kind of the MIT Technology Review was talking about this new term, infodemic, and you see the subtitle, fueling panic, racism. So again, kind of the focus is on the potential harm, not that much about whether it's true or not. And here's kind of what I was telling you about, right? So disinformation is something that is about the intersection of misinformation, malinformation. Misinformation is something false, and malinformation is something harmful, and disinformation is something that is both false and harmful. And this is kind of the evolution of the term that I was telling you about, right? From focusing on factuality to focusing on both factuality and harm to focusing on harm only. And yeah, we had like some interesting schema and so on and so forth, but now that the pandemic is, you know, gradually going away, I'm not going to bore you with that, even though it was a very interesting schema, holistic approach that was putting together the perspective of fact checkers, society policymakers, journalists, fact checkers, and so on. And I want to kind of say that this was team's work. Kind of a lot of this was done as part of the TMB project, you know, in QCRI, which was kind of cross-disciplinary across different groups. And this doesn't even kind of, you know, even we have external collaborators. So kind of some of the, and we had a collaboration with MIT on that. He worked with many students from Sofia University. And yeah, we have been collaborating with different organizations on this. And to conclude, so we should avoid two things. One is that we should not focus only on factuality. We should also kind of remember the harm. That's number one. Number two is kind of there is also claims and there are also perspectives, right? And multiple, the same thing can be true or can be kind of when you look from different perspectives. So I would just want to warn you about the potential kind of the danger of kind of black and white thinking. And this, I want to give the stage for Ahmed to make an announcement before we go to questions.
I suggest to delay the announcement a little bit and maybe take a couple of questions from colleagues because we have about 7 minutes for questions to open staff, and then we'll make the announcement. So if someone has a question?
Questions?
I can start with one. So most of us here work on speech, and there have been interesting efforts in paralinguist field, such as emotion, and you highlighted on it the real emotion versus acted emotion, and the work that has been done in the deception, also in the speech, acted in both of them. But the reality is, in the emotion, it's very challenging to find the 5 emotion in real scenario, and that has been slightly easier to find acted emotion. But although there is a good effort happening in getting real emotion in building the model that be able to distinguish between them, what's the reality to have difficulty in collecting the disinformation in the speech across different fields? Because I could be professionally a liar as anchor speaker saying something. So would you tell us a little bit more about the deception and collecting, how to build the corpus for a disinformation in speech? What's the way?
So, okay, I mean, okay, the question is, how did we build corpus for disinformation speech? So, okay, there have been like different tasks, and we have like talking about different corpora. So let me see. I can maybe kind of, and there are many different places where speech can help. So let me kind of maybe give you an idea about something. So here, for example, there's a data set of political debates, and so it was kind of relatively small. At some point, we have like building a bigger one, where you have the debate and you have human fact checkers have fact checked different claims, and you kind of look into those claims that were fact checked. And we are asking the system only for those claims for which you know the factuality, whether they are true or false. And kind of course, you are free to go into use any information in the world you want, just like in general. But then the question was kind of, is there something that the speech modality is giving us on top of this? And actually, it was kind of helping. This is one thing. And then you can also ask the exact same question, but in the exact same data set, you can ask which of those are interesting to fact check, because you know that it was fact checked. And in one case, you ask, is this true or not? In the other case, you say, I don't care whether it's true or not. I care that And this claim, somehow there's something interesting about this sentence because it was fact-checked and the others were not, right? And the question is, what is interesting about it? Okay, it can be the entities that it mentions, it can be that it's similar to other claims, it can be the sentence structure, it can be like who is saying it, it can be kind of the discourse structure, it can be that speakers are arguing between themselves. So, for example, if one debater says, something, the other one says, I didn't say that. Now they are arguing about this. Maybe this is interesting to fact check, right? Because they are arguing about it. So kind of there are a lot of things in the discourse, but the question is, what is there in the speech signal that actually can help, right? Yeah, this is kind of one data set. The other data set that I have kind of mentioned about is this one about the YouTube channels. So basically what you do is you went into media bias fact check, and they have about 3,500 websites that are kind of manually fact checked, and kind of they have some idea about them, about their virtuality and bias. And then we went and we checked for each of them whether they have a YouTube channel, and if they did, kind of we collected certain number of videos from each of them, and then we did analysis of the audio signal of those videos. Yes.
Hi, thanks for the talk. Interesting one. I think I have a question about one of the early slides where you have multiple languages and this long tail for
This one?
multi-languages.
Multiple language, yes.
Yeah.
I skipped it very quickly, but I can explain what.
Yeah, over here. So, so my understanding about facts is they're language agnostic. So if it is a fact in English, then it's a fact in all languages. So I'm thinking if the fact-checking systems in low-resource languages could leverage this fact that if it has a good machine translation system, then we should be able to get good performance for low-resource languages as well. Is that true?
Yes. Okay. So it's the mood. There's a need for multilingual data sets, right? And the reason we need multilingual data sets, at least for evaluation, right? I mean, also for training, but also for evaluation, because the topics that are relevant in different languages are different. I mean, maybe kind of claims by different kinds of politicians or about different kinds of entities, right? So kind of the things that are being discussed, there are things that are universal. So when COVID-19 came, there are all kinds of claims, and the same claims were repeated across different languages. But there are things that are kind of, more region and more culture and more kind of, community specific. So kind of you need kind of those data sets. And now there are different things. I kind of want to stress again the difference between a claim and the news. So fact checking is about a claim. Fake news detection is about an article. Now, and there's a difference. The difference is that the claim that is fact checked is typically something that humans have analyzed the news, have analyzed the tweet or whatever, and they come up with the crystal definition of the claim. But this is not how it originated, right? So it's some normalized version of it. This is not the version that you are going to find in the wild, right? And there are many kind of fact-checking initiatives. They just give you the specific claims. And there are not that many data sets of fake news where you have the entire article, right, where it originated. It's actually a lot of work. And in this data set, this is coming from Facebook. There are 12,500 URLs that were actually shared more than 100 times on Facebook, and that were actually fact-checked, and we know they are fact-checking labels, and this is kind of something new. And this is similar to this one. This is done on the fake news net, which is based on PolitiFact and Gossip Cup, those two. And this one is kind of bigger and also has other languages. So this is the thing. And kind of the languages are very important because kind of some strategies for this misinformation is like, okay, instead of putting this in English where maybe things are monitored and all that, what I'm going to do is I'm going to put it in Spanish in some Latin American country. What's going to happen next is that from there it's going to go into Spanish-speaking community in the US, and from maybe also in Spain, and from there it's going to go everywhere. And then it's much harder to track it where it came from and so on and so forth. right? And then the other thing is the platforms. When you kind of look into smaller communities, it's not just Facebook or Twitter. In certain countries, actually, it's WhatsApp. And those are even closed communities. And then how do you fact check there? Because it's like end-to-end encoded. Okay, there's also privacy issues and things. And actually, looking into previously fact check claims is one way to do it. One solution that I have seen people have been doing in India. It's something that you can install on your phone, just like you install an antivirus program, and you have like a list of known signatures. So then you install this app on your phone. It doesn't send anything anywhere. It has the list of fact check claims, and if somebody sends you something or you type something that is known to be false, it's going to tell you, right? So kind of this is a very interesting way to do fact checking on your device in a privacy preserving way in an encrypted platform.
Maybe we have one more question. Yeah.
Yeah, thank you. That's very interesting talk. A bit of maybe a cynical view, but people at the extreme, they tend to believe what they want to believe, regardless if it's fact-checked or not. So kind of what are your thoughts on how we can reach out to these people and actually try to, make fact-checking actually influential?
Yeah. Okay, so let me kind of, let me try to see if I can connect. So kind of the question is, what can we do, right? Kind of, it's about intervention, right? I have been talking only about detection, right? So kind of, what can you do? So if I look, so this is a demo that we have built, kind of, you can go in there and you can analyze the propaganda techniques. So you can actually teach people the specific propaganda techniques that are being used, okay? So it's not really, sorry? Oh, you don't see it. That's good. Let me see. Okay. Okay. So now it's a bit challenging for me because I don't see it, but okay. So anyway, here you have, let me see. Okay, so you have different kind of propaganda techniques that are there in the text, and basically, if we show you this, you can eventually, after interacting a little bit with the system like this, we can actually learn them, right? It has happened to me, it has happened to other people that have been interacting with the system like that. And the next time you see the news, you actually recognize the techniques. And one way kind of about the intervention, one important thing is that you don't need to be confrontational. If you're confrontational, right, people are going to say, no, but I mean, I really believe it. But one thing that you can do is, unfortunately, I cannot, well, I can show you, if you hate CNN, I can show you the propaganda in CNN. If you hate Fox News, I can show you the propaganda in Fox News. And of course, there's a little bit, here and there, especially in kind of editorials, whose kind of, goal is actually to have a stance, to be more provocative. I mean, it's kind of different from kind of actual news reporting, right? And it's not, I'm not going to tell you something that is confrontational and inconsistent with your views. I'm going to say, yes, you are right, they are propaganda. Now I'm going to show how. But in the process, hopefully you're going to learn those techniques. And then next time that you're reading whatever you're reading, you might say, wait a minute, I mean, why are you doing this to me, right? Kind of, I mean, this is just one example. And there are probably kind of other ways to do it. I mean, intervention is a big topic, right? And it's not easy because, as you said, it's about beliefs, and I cannot convince you that your favorite team didn't play better yesterday. Sorry, I mean they were better. It's the referee's fault. Yeah.
All right. I think with this come to the end of the talk. Would like to thank Prislav for the interesting talk. Thank you very much.
Oh, wait. So now we have the last slide.
So we have a couple of quick announcements to make. Some colleagues complain because some of the posters have no one standing next to it. Just a reminder, we have the posters for the full day, the morning and the afternoon. So make sure that the poster that you are looking at is the poster for the day. You can always look at the poster in the morning now or the poster in the afternoon during the day. This is the first one. The second thing is just at 5 o'clock today, and tomorrow we'll have an industrial talk. So today we have 3 talks. The first one from Qatar National Research Fund, and the second one from Google, the third one from Amazon. That's going to be between 5 and 6 tomorrow. We have more industrial talks. The first one from Aptec, the second one from LXT, and then the third one from TransPerfect, and the last one from SCI. We're waiting for the confirmation. The third announcement that we'd like to make is at 6 p.m. today. We know that you guys haven't eaten enough, so it's not a welcome reception, it's a welcome dinner. So, that's going to be interesting. It's going to be here as well from 6 to 8. Make sure you attend, and we look forward for it. And now we're going to start the poster presentations. Thank you very much.